Hi everyone, my name is Matt, also known as the UKAstroNut, and today I'm going to be carrying on from a video last time. So I did a video on what are exoplanets. So today I'm going to be telling you how we actually find exoplanets. So if you don't know what exoplanets are, they're just planets that go around other stars. So in our solar system we have the Sun and we have 8 planets going around it, but there are loads of other stars with loads and loads of other planets going around them all the way through our galaxy and through the rest of the universe. And it's only recently that we've actually been able to see and discover these other planets. So like 1992 the first one was ever discovered, and this was discovered because there was a star that just kept emitting a pulse of light at a really frequent kind of level, and what happened was a planet was orbiting around the star, and as it passed in between the star that was flashing and us, what was happening is it was blocking out some of the pulses. So we're seeing these really regular pulses of energy, and then it would suddenly miss one, and then it'd keep going, and then it'd miss another one. And we were detecting this planet going in between the star and us, and it was blocking this sort of pulse of radiation. So in 1992, this was the first way that we actually discovered an exoplanet. And this was really the only way that our technology could allow us to do this. But since then, technology has got significantly better. And there's now loads and loads of other ways of detecting exoplanets. But there's kind of 3 main ones, and there's also another one as well, which I'm going to go through because it's sort of, well, it's quite a nice, interesting way of doing it as well. But so the pulsar way is one, but there are some other ones. So they kind of fit into 2 categories in general, the way which we detect exoplanets. So one is to do with the light or the radiation from the star being blocked by the planet. So, as I said a second ago, there's the pulsar, which does the exact same thing with the planet passing in front of the star, and it blocks some of this radiation, so we can't see it for a little bit. And then the second one is on the same kind of idea, but it just doesn't rely on the star being pulsing and sort of sending out bursts of energy, and it's called the transit method. So the transit method, you're looking at a star, and you know it has a certain brightness, and the brightness doesn't change very much. A brightness of a star, with most stars, remains pretty constant over a short period of time. So if it suddenly goes really dim for a few minutes or so, it is a bit strange. I mean, why would a star suddenly go dim? Why would it suddenly let out less energy from any other time? Well, it probably isn't. It's probably just because a planet is passing in front of it. So if you actually get a torch, and then obviously you just put your hand right in front of the torch and you block the torch, you'd see there was no light. But if you put your hand part of the way across the torch, it becomes slightly less bright. But you'd still see the torch. It would still be bright to you, but just slightly less bright. So that's basically what the transit method is. You'll basically look at a star, the planet passes in front of it, and the light from the star is just reduced down. So this is one way of detecting exoplanets. And it's in the exact same fashion as the other pulsar method as well. So the other 2 methods rely on basically being able to see the star moving. Now, this is a strange thing as a result of gravity. Okay, so we know that the star, the sun at the centre of our solar system, gravitationally pulls on all of the planets. And this is what causes the planets to just keep going round and round in an orbit. Okay, if there wasn't the gravity, the planets would just slingshot off and we'd all be flying through empty space. But it's the gravitational pull from the star that keeps all the planets in their orbit and going around and around. But equally, as the sun is gravitationally pulling on the planets are also gravitationally pulling on the sun. So although the sun has more mass and more pull, and so the planets go around it, it's also slightly moving as it's being pulled by the other planets. So this happens in other exoplanet systems as well, and it's very, very small because it's to do with the ratio of the masses of the 2 bodies, the mass of the planet and the mass of the star. But if they're very big planets, the star can actually move significantly, enough that we can actually see it moving because of the pull from the planet. So there are 2 methods here. There's one called astrometry, and this is where if we look at a star as the planets go around it, we can see the star's position in space moving slightly side to side. Because if the planet is over here, it's going to pull towards it here, and as it goes around, it's going to move, and it's just going to keep moving like this. And we're just going to have to see it going side to side. So this is the astrometry method. And then there's a radial velocity method, which is the opposite. So we see it coming away and towards us. So we see it coming like this, and it will just move very slightly towards and away from us. And if you know what the Doppler effect is, so the Doppler effect is that thing when an ambulance comes towards you, and it makes the high-pitched noise of the siren as it comes towards you, but then as it passes you, the pitch or the frequency decreases. So it goes, and it sort of goes up and then down as it passes you. That was a very terrible ambulance siren noise, by the way. But that's basically what the Doppler effect is. We can kind of see this with light as well. So as the star is moving towards us, the light from the star appears a bit more blue, so it goes to a shorter frequency, and as it goes away, it moves a bit to red. So all we see the stars going a little bit blue, a little bit red, a little bit blue, a little bit red, and it just keeps doing this. And we can actually see this change in the light, and then it tells us there's probably an exoplanet there that's pulling on the star. So those are the two kind of general ways, and then the individual ways within them has to detect stars. So it's mainly by blocking some of the radiation, some of the light from the star to make it a bit fainter, and the actual wobbling of the star because the planets in the system around it are pulling on it. But there's also the really interesting one, which doesn't give you as much scientific information, but it's much nicer, and that's just actually visibly seeing the planet. So it doesn't happen very often, but sometimes the planet is close enough to us and it's bright enough that we can actually take a picture with a telescope and we can actually see the star in the centre, and we can identify a tiny little bright spot off to the side, and we can find an exoplanet that way. So it's a lot easier to actually see this when you know where the exoplanet's going to be, and then you look at the picture and you go, right, well, it should be in this part of the picture, and you go, oh yeah, there it is. It's much harder to actually detect it outright just because our telescopes aren't quite good enough really to be able to do this. But you can actually see it, and potentially it's possible to detect exoplanets this way. So those are kind of the 4 or 5 different ways of detecting exoplanets, and as they sort of come in 2 main categories: blocking of light and the wobble of a star. And these techniques are really good. I mean, we've detected over 1,800 planets as of me making this video, so we're really getting successful at this. And considering we only detected the first one in 1992, we're definitely improving. We're detecting more and more exoplanets each day. So yeah, if you haven't checked out the previous video, there's an introduction to exoplanets to do as well, because it might be quite useful if you're interested in this kind of thing. And check out some things. Check out like the NASA Kepler space mission. So that's detecting exoplanets itself, and you can research up about that telescope and find out more about it. But exoplanet detection and exoplanets in general are a really interesting and up and coming field in astrophysics at the moment. So it's really worth looking into if you have a spare few moments, or just keep watching my videos and I'll try and explain it all for you. Thank you very much for watching. Don't forget, hit the little subscribe button please, tell all your friends and everything. And if you have any questions or comments or anything, leave them in the video, and I'll try and answer them for you, and I'll do individual videos about your questions and things. Thank you very much for watching, and I'll see you guys soon.